Hello friends, that here we will discuss about the properties of acids. Well, basically properties refer to two types. One is the physical property. Another is the chemical property. But the first we will discuss about the physical properties. So in the physical properties, the first one will consider about, the state. If you look at the first 9 members of the monocarboxylic acids, first 9 members, the first 9 members of the monocarboxylic or aliphatic carboxylic acids are colorless liquids. Are colorless liquids with sharp odor. That means smell. So the first 9 members of aliphatic monocarboxylic acids are colorless liquids with a sharp odor. And higher than that of this 9 are wax-like solids. Yeah. So this is about the state of monocarboxylic acids. Now we'll discuss solubility. The monocarboxylic acids, the lower members of the monocarboxylic acids, monocarboxylic acids are soluble in water. Yeah. So in solubility, that we need to remember, the lower members of the monocarboxylic acids are soluble. And next we'll discuss about boiling point. The boiling point increases as the molecular masses increases. So the boiling point of monocarboxylic acid increases if the molecular masses increases due to the interactions. Similarly, the melting point. Melting point, it increases with the even number of monocarboxylic acids. And it decreases odd number. That means the molecular, the even number. If the molecular mass is of even number, then the melting point increases, and in the odd number, the melting point decreases. So this is all about, the different physical properties of carboxylic acids. That is from state, solubility, boiling point, and melting point. That here. In the examination, in the bit questions, it may come in the examination that explain, the state, explain the solubility, the boiling point or the melting point of the acids. Now, most importantly, that we discuss about the chemical properties of monocarboxylic acids. Well, if you look at the chemical properties of the acids, we need to explain about the acidic nature. First of all, that we need to explain about the acidic nature of the acid. That means we have, RCOOH. So when RCOOH gets hydrolyzed, then what happens? RCOO minus plus H3O plus is obtained. So this is H2O and one more H, that is H3O plus. So RCOO. So if we'll, the constant, the equilibrium constant is that RCOO. Concentrated molar mass of RCOO minus and H3O plus and RCOOH. This is the equilibrium constant of the carboxylic acids. But now we need to explain whether this RCOOH act as an acid or not. Let's have a look. We have RCOOH. If you look at here, 2 lone pairs will be there, and here 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. No, only 2. Okay. And this structure can also be, this lone pair of the electrons, will be attracted by this carbon atom, and here this pair will be transferred to this oxygen atom, and it can also be written as 1, 2, 3, 4, 5, 6. A negative charge is created, and here that is a positive charge is created. And what about this H? It will be released as a proton. That means, if you look at here very carefully, that the acid has the resonating structure. That means it can also be written as RCOO minus and H plus. That if you will write RCOOH, if you will dissociate RCOOH, then what do you get? RCOO minus plus H plus. So how can we explain the acidic nature of this acid? We have RCOOH, right? And it consists of, the oxygen atom consists of the lone pair of the electrons, and due to the resonance, it forms the carboxylate ion, wherein the positive charge is created by the oxygen atom since it loses the pair of the electrons, and finally it releases a proton. That's why it behaves as an acid. So the substance which is having the tendency to release a proton, or which is having the tendency to donate a proton, then that substance is to be regarded as, acid. So this RCOOH, we can easily say that it acts as an acid due to its resonating behavior. And since it shows the resonance, that's why it behaves as an acid. Resonance how? Here the shared pair of the electrons will be attracted more towards the oxygen atom. That means the oxygen atom attracts the shared pair of the electron towards itself. As a result, the oxygen atom, it gains a negative charge. Similarly, the pair of the electrons here will be shifted to this bond, and finally one more bond will be created, that is a pi bond, wherein a positive charge is created by the oxygen atom. It will be created with the oxygen atom. That's why this is a carboxylate ion. Carboxylate ion. And finally a proton is released. Since it releases the proton, that's why we can say that it can express the acidic nature of, that means the carboxylic acid behaves as an acid. In the examination point, it will be asked to you that explain the acidic nature of carboxylic acid. Due to the resonance, due to the resonance, the oxygen atom, by losing the electrons, it will gain a positively charged. Similarly, one more oxygen, and it attracts since the oxygen is more electron negative than that of the carbon atom, then the shared pair of the electron will be attracted more towards itself, and finally it produces O minus, and it is releasing a proton. That's why it behaves as an acid. Now we will discuss the strength of the acid by using the various substituents. So how can we explain the strength of the acids? Suppose we have, you see, HCOOH. So HCOOH is formic acid. I can say that the formic acid is greater than the acetic acid is greater than propanoic acid. Now you can ask me that why the formic acid is greater than that of the acetic acid, that why the formic acid is stronger than acetic acid. The acetic acid, if you look at here, in the acetic acid you have alkyl group. Here in the acetic acid you have alkyl group, and this R is basically an electron releasing group. Or we can say electron repelling group. Electron repelling group. So since the R is present in this acid, that is the alkyl group is present in this acid, you know that the alkyl is electron releasing group or electron repelling group, which causes the plus I effect, positive inductive effect. That's why the acidic strength of it decreases. That means if the alkyl group increases, if the electron releasing group increases, or if electron repelling group increases, which causes the plus I effect, then the strength of the acid gets decreased. That's why the formic acid, since the alkyl group is not there, here hydrogen atom is attached to the carboxyl group. Since the alkyl group is not there, that's why this formic acid is more stronger than that of acetic acid. And why, which it can be explained. So if you are asked the question that how can we explain whether the formic acid is stronger than that of acetic acid, that you need to remember this plus I effect. On the basis of this plus I effect, what does the plus I effect indicate? The plus I effect, in the plus I effect we have electron releasing group or electron withdrawing group, and more the number of electron releasing or electron repelling group, lesser will be its strength. That means acidic strength. So that's why the formic acid is greater than acetic acid, and acetic acid is also greater than the propanoic acid, wherein the alkyl group is larger in case of the propanoic acid. So in this way, on the basis of this plus I effect, that is the positive inductive effect, we can easily explain that how the formic acid, why the formic acid is greater than the acetic acid, and why the acetic acid is greater than propanoic acid. So if in the examination it comes that which acid is stronger, whether the formic acid or acetic acid, then what do you say? Obviously you have to say that the formic acid is stronger than acetic acid. But why? Due to the plus I effect, and since it causes the plus I effect, that's why the formic acid is greater than acetic acid. And what is that plus I effect? I had already explained you in the previous lectures. So if you do not have the clarity on that matter, then I wish you to go back to the video lectures and watch that again. Well, this is all about the strength of the acids. Now we will come to the different chemical reactions of this monocarboxylic acids. So if we look at the chemical reaction, the first one we have action with metals. So the metals can be the various things, the metals like sodium, magnesium, zinc, or any others. Suppose I have taken the two molecules of carboxylic acid. When it reacts with the metal sodium, then it gives RCOONA, sodium salt, along with hydrogen gas is evolved. So what is the specific example? This is acid and this is sodium salt of acid. So let us take the specific example CH3COOH. If it is treated with Na, then CH3COONA, sodium acetate plus H2. This is sodium acetate and here this is acetic acid. So this is the first chemical reaction, my dear friends. Action with metals. When acid reacts with metals, it gives the salt with the liberation of the hydrogen gas. If that same acid reacts with base, what happens? We'll look at. Action with alkali. So we have acid RCOOH. When it reacts with NaOH, then it gives RCOONA, sodium salt of acid, but here the water molecule is removed. If you will give the specific example, CH3COOH plus NaOH, this is sodium hydroxide. CH3COOH, acetic acid, when it reacts with sodium hydroxide, then it gives CH3COONA, sodium acetate plus water. So if you observe it very carefully, that the acetic acid reacts with sodium hydroxide to give the sodium salt of acid, and finally the water molecule is removed from here. And this reaction is very simple to understand. Here the acid reacts with the metal, and finally how? Well, if you will dissociate this acid, then you will get RCOOH. If you will dissociate it, RCO minus and H plus, then sodium Na plus. So the negatively charged of this compound will react with the positively charged. That's why in this way RCOONA is obtained, that is sodium salt of acid is obtained, and hydrogen gas is liberated. But if the same acid reacts with an alkali, which is a base, then here this is partially positive and then this is negative, or this is positive and this is negative ion, and this is negative and this is positive. So the positively charged part of this one will react with the negatively charged one, and finally it produces the water molecule. And RCOO minus, this will react with Na plus and RCOONA, that is sodium salt of acid. If you will put the specific example, then CH3COOH plus NaOH gives rise to CH3COONA, that is CH3COO minus and H plus, right? Similarly Na plus and OH minus. This CH3COO minus, it reacts with Na plus, which is a positively charged one, and finally it gives CH3COONA plus water. I think here something very different. Let me write it for you so that if you will dissociate acetic acid, you will get CH3COO minus and H plus. I have Na plus and OH minus. If you will dissociate this sodium hydroxide, you will get Na plus and OH minus. You know that the negatively charged of this one will react with the positively charged, and in this way CH3COO minus and Na plus is obtained, and here the H plus reacts with the OH minus to give the water molecule. That means when acid reacts with a metal, simply a metal, then it gives the sodium salt of acid with the liberation of hydrogen gas. Similarly, when that acid reacts with an alkali, which is a base, it also gives the sodium salt of acid. But one more thing, here water molecule is removed, and this is what the second method, that is with action with alkali. Now we will discuss the third method of the preparation of monocarboxylic acids. So, well, I was just talking about the chemical reaction but not the preparation, which is what the preparation already it has been the class for the preparation was taken in the previous lecture. So the third chemical reaction is that reaction with carbonates and bicarbonates. What happens if the acid reacts with carbonates and bicarbonates? Suppose I have the acid RCOOH. When it reacts with Na2CO3, then what happens? It gives RCOONA, sodium salt of acid is obtained, carbon dioxide gas is obtained along with the water molecule. So if I will take, this is acid, and acid on treatment with sodium carbonate, Na2CO3. So what is the name of this compound? Sodium carbonate. On reaction with sodium carbonate, it gives the sodium salt of acid, carbon dioxide gas along with the water molecule. So if I will take the specific example, first of all let us take the HCOOH, formic acid. So when formic acid reacts with sodium carbonate, then the sodium carbonate will be broken, HCOONA, that is sodium formate. Sodium formate is obtained plus carbon dioxide plus water molecule. Similarly, this is formic acid. If I will take acetic acid, COOH plus sodium carbonate, what do I get here? I do get CH3COONA. This is sodium acetate. Yeah, sodium acetate plus carbon dioxide plus water. Carbon dioxide and water are very common if the reaction takes place with carbonates and the bicarbonates. That's you need to remember. Suppose I have what? Acetic acid. If this acetic acid reacts with sodium bicarbonate, then the same it reacts, that is the CH3COONA. Sodium acetate is obtained, carbon dioxide and water. But if the acetic acid reacts with sodium carbonate, then 2 molecules of the sodium acetate is resulted with carbon dioxide and water molecule if 2 acetic acid is taken. But if sodium bicarbonate is taken, then no 2 molecules of acid is not, that means it is not necessary to be taken, and finally it gives the sodium acetate plus carbon dioxide plus water. So if an acid reacts with the carbonates and the bicarbonate, what it yields? The main product it gives, that salt, that is the sodium salt. Or if any this is sodium carbonate I have taken, if I have taken the magnesium carbonate or the zinc carbonate, it based on what? That means anyhow the salt is obtained. If it reacts with carbon dioxide and bicarbonate, salt is obtained, but carbon dioxide and water molecule. Carbon dioxide and the water molecules are the common byproducts which are released from here. That is what the reaction with carbonates and the bicarbonates. Now we will look at the next chemical reaction, that is the fourth chemical reaction. When the acid reacts with alcohol, then what happens? Well, if acid reacts with alcohol, then what happens? We'll see. Suppose we have acid RCOOH. When this acid reacts with alcohol, a reversible in the presence of concentrated sulfuric acid, then it gives ester along with water molecule. How? If this acid gets dissociated, then you will get RCO minus and H plus. If this R, this OH minus, let us take R plus, and RCO minus reacts with R plus, and finally it gives ester. That means here the product which is obtained is known as ester. That's why this reaction is also known as esterification. Esterification. So when acid reacts with alcohol in the presence of concentrated sulfuric acid, it gives the ester along with the water molecule. And the reaction is also known as esterification, since the ester is a product which is obtained here. If we will take the specific example, CH3COOH. When it reacts with C2H5OH, concentrated sulfuric acid, then the CH3COOH, the CH3COO, it reacts with C2H5 and it gives CH3COO C2H5 plus water. The name of this product is ethyl acetate, and this is acetic acid. So this is one of the most important and relevant reaction for the examination. When acid reacts with alcohol, it gives the ester, and if ester gets hydrolyzed, again it gives the acid as well as the alcohol. That's why this reaction is reversible in nature. But what is the agent used here? Here the concentrated sulfuric acid is used as the agent. So this is all about the fourth reaction, that is reaction with alcohol. Now we will move on to the fifth number chemical reaction, that is formation of amide. Formation of amide. Suppose I have acid. When this acid reacts with ammonia, it gives RCOONH4. Look at here, this acid RCOOH, this is ammonia, and this NH3 and 1 hydrogen, that is NH4. So RCOOH, this is ammonium acid. So ammonium salt of acid, if the ammonium salt of acid is further heated, then amide is obtained. RCOONH2 plus RCOONH2 and plus water. So this is amide. That means the amide can be formed from the acid. When acid reacts with ammonia, what happens here? First of all, it gets added. So ammonium salt of acid, that is RCOO, NH3 and 1H, that is NH4. So RCOO NH4. So ammonium salt of acid is obtained, and if that is heated further, then amide results with the liberation of the water molecule. Let me give you the specific example. Here we have, you see, HCH3COOH, acetic acid. When this acetic acid reacts with ammonia, then it gives CH3COONH4. That is ammonium acetate. Look at here, the CH3COO and NH3 and 1H, that is NH4. So CH3COONH4. What's the name? Ammonium acetate. Ammonium acetate is obtained, plus on further heating, it gives CH3CONH2, that is acetamide. Acetamide with water molecule. So in this way, the amide formation takes place in a very easy manner. The amide can be formed by the acid by the two steps. So this is all about the fifth chemical reaction, that is the formation of amide. Now we will discuss the sixth chemical reactions of monocarboxylic acids.